So, good morning, welcome to Sakala Vidya educational channel. So, welcome to our engineering mathematics classes. So, in the last session up to part 1 to part 5, we have discussed differential equations, that means concept of the differential equations, how to form the differential equations we have completed. So, now we are going to study how to solve the differential equations. In this part, so today we shall concentrate on the differential equations of the first order and first degree. Differential equations of first order and first degree. So, under part 6 we are going to cover. So, first let us have a discussion. So, what is the definition of first order and first degree differential equation? So, after discussing the definition of the first order and first degree differential equation, so how can we classify this first order differential equation? That means how many types we can divide it. So, how to solve them by each and every one by one, very clear manner we are going to discuss. So, that means actually this series is for moreover all the problems, most important problems, and all the problems will be covered during our sessions. So, it is not meant for examination point of view, but sometimes, but actually those videos also after completion of this chapter for examination point of questions, previous examination questions also will be dealt later. So, first let us have a discussion. So, what is meant by the definition of here, what is the definition of first order and first degree differential equation? Okay, let us start. So, first order and first degree differential equation. So, sometimes this definition may be given in the examination also. See, an equation of the form very simple to remember, of the form dy by dx equals to f of x comma y, is called a differential equation of first order and first degree This is enough. If you are asked the definition of the first order and first degree differentiation, simply write down dy by dx is equal to f of x comma y. The equation which is in the form of dy by dx is equal to f of x comma y is called differential equation of the first order and first degree. So, that is only. Okay, now how do we classify the differential equation? Let us have a discussion on that one. See, here in general the first order differential equations can be classified as follows. The first one is variables separable, second one is homogeneous equations and equations reducible into homogeneous form, third one is exact equations and those which can be made exact by use of integrating factors, fourth one linear equation and Bernoulli's equation. So, we will study one by one. So, today let us concentrate on variables separable. That means, once again let me repeat, the first order differential equations can be classified as follows. There are four, it may be defined as four ways. One is variables separable, second one homogeneous equations and equations reducible to homogeneous form, third one is exact equations and those which can be made exact by use of integrating factors, fourth one is linear equation and Bernoulli's equation. Okay, now what is meant by the variable separable? Next, let us have a discussion on that one. Variables separable, and also now We shall discuss problems on variables and separable also. First, let us consider first order and first degree differential equation. So, already we have studied the definition of the first order first degree differential equation. Let us consider first order and first degree differential equation. dy by dx is equal to f of x comma y. Suppose if it can be expressed as, if it is expressed as g of y dy is equal to f of x dx, or this can be rewritten as f of x dx minus g of y dy is equal to 0. Say this equation 1 form. So, now if the first order and first degree differential equation is written in the form of g of y dy is equal to f of x dx or f of x dx minus g of y dy is equal to 0, then this is called variable separable. This form is called. So, here what do we say? F comma g are actually continuous functions in variable of a single variable. So, now here write down where f comma g are continuous functions in one variable. Now, this equation 1 is said to be variables separable. Variables and separable. Simply we can say that this is separating the variables. Also we can say that. So, this is called variables separable. So, now how to solve this one? So, that means for example, so from consider equation 1, integrate on both sides, we get the general solution. So, how to solve means once again integrating equation 1 on both sides. So, then we get like this: integral of f of x dx minus integral of g of y dy equal to integral of 0 means constant term you will be getting, say equation 2. The equation 2 is the solution, general solution of equation 1. So, this is the general solution. Actually, this is the method of solving the variable separable. If the given first order first degree differential equation is variable separable form, so this method is to be adopted. So, using this method the variable separable form can be solved. So, then we get the general solution. So, let us proceed for the questions now. So, now problems, write down problems. It's very important now. First question, first problem. Solve the differential equation solve the differential equation. Solve the differential equation. dy by dx plus root over 1 plus y square upon 1 plus x square equal to 0. So, how does look like? It looks like dy by dx is equal to f of x comma y. So, it is nothing but actually first order first degree differential equation, but let us check can it be put in the variable separable form. So, after writing in the variable separable form, so then by integrating we get the solution. So, now let us try to solve this question. Solution. So, here write down given differential equation. Given differential equation. Given differential equation is dy by dx equals to dy by dx plus root of 1 plus y square upon 1 plus x square equal to 0. So, now transposing this root of 1 plus y square by 1 plus x square to the right hand side, then you get dy by dx equals to minus root of 1 plus y square by 1 plus x square. So, just think the root of 1 plus y square by 1 plus x square, we can write root of 1 plus y square by root of 1 plus x square. So, this we can write negative of root of 1 plus y square upon root of 1 plus x square. So, now we can put in the variable separable form. So, this bring root of 1 plus y square to the left hand side. Now, this can be written as dy divided by root of 1 plus y square you can write equal to, now dx, this we can write minus dx by root of 1 plus x square. Again, if you want, you can transpose the term of right hand side to the left hand side. So, that means we get now dy root of 1 plus y square plus dx upon root of 1 plus x square equal to 0. Now, this is nothing but actually which form, that is variable separable form. So, now integrating on both sides we get our solution. So, integrating on both sides. So, integrating on both sides. Integrating on both sides. Integrating on both sides. Okay. So, on integrating on both sides means integral of dy by root of 1 plus y square plus integral of dx upon root of 1 plus x square equal to constant term. Integral of 0 is constant, we can write it. So, my dear students, here basic concepts are to be remembered to solve this formula. What is the concept to be remembered? Very important, this concept. What is the concept? Means integral of 1 upon under root of 1 plus x square dx. This is one of the standard formulae of integration. So, this is equal to sin h inverse hyperbolic function, sin h inverse x plus constant of integration. So, that means now we can write here, we can write, see, integral of dy by root of 1 plus y square is, we can write sin h inverse y plus integral of dx root of 1 plus x square is nothing but sin h inverse x is equal to constant. So, therefore, this is the required general solution. general solution. So, this is our answer. So, I hope you might have followed. See, once again let me repeat. The given differential equation is dy by dx plus root of 1 plus y square by 1 plus x square is equal to 0. So, as it is in the form of dy by dx is equal to f of x comma y, it is nothing but first order first degree differential equation. So, let us check, can it be put in the form of variable separable form. So, transposing this side, then what do we get? Dy by dx is equal to minus root of 1 plus y square by 1 plus x square. So, this we can write minus root of 1 plus y square by d root of 1 plus x square. You just actually bring root of 1 plus y square this side and dx to the right hand side. We can write dy by root of 1 plus y square is equal to minus dx by root of 1 plus x square. Bring minus dx by root of 1 plus x square to the left hand side. So, we get dy by root of 1 plus y square plus dx by root of 1 plus x square is equal to 0. Integrating on both sides. So, integral of dy by root of 1 plus y square plus integral of dx by root of 1 plus x square is equal to integral of 0 is constant, because derivative of constant is 0. So, that is why integral of 0 is c, constant, or you can put like this c also, no problem. What is the concept? Basic concept you need to remember while integrating this one. Integral of 1 upon root of 1 plus x square dx is sin h inverse x plus c. So, integral dy by root of 1 plus y square is sin h inverse y, sin h inverse y, plus integral of dx by root of 1 plus x square is sin h inverse x is equal to constant. This is the required general solution. Okay, let us move to the next question. Second question. So, write down all of you second question. What is the second question? Solve dy by dx is equal to e to the power of x minus y plus x square into e to the power of minus y. So, just observe e to the power of x minus y plus x square e power minus y is nothing but function of x comma y. So, dy by dx is equal to function of x comma y. So, obviously it is first order and first degree differential equation only. So, now we need to check whether it can be put in variable separable form or not. If we are able to put in variable separable form, so just by putting variable separable form, integrating on both sides, we get the general solution of the given differential equation. So, that process has to be followed here. Okay, let us proceed for the solution. Given differential equation is differential equation is dy by dx is equal to e to the power of x minus y plus x square into e power minus y. Okay, what is the concept here we need to make use of? So, let us use the basic concept from algebra concept. So, what is the concept means? We have a to the power of m minus n equal to a to the power of m upon a to the power of n, you can write, or this can be written like this also, or we can write a to the power of m multiplied with a to the power of negative n also we can write. Both ways we can write. So, using this concept, now we can write this one as e to the power of x into e to the power of minus y plus x square into e to the power of minus y. So, can we take it any common from e to the power of x into e to the power of minus y plus x square into e to the power of minus y? Yes. Why not? e to the power of minus y we can take out common. E to the power of minus y times or multiply with e power x plus x square. See, e power minus y is the function of y, whereas e power x plus x square is function of x. So, they can be actually separated now. So, that means now bring e power x, so cross multiply dx this side and e power minus y this side, we get dy by e power minus y is equal to, we can write e power x plus x square into dx. Clear? If you cross multiply again, what do we get? Dx this side, e power minus y this side. So, now the here variables have been separated now. So, this is actually variable separable form, variables separable form, integrating on both sides, but before integrating actually this can be written e power y dy, because we have the formula 1 by a power minus n is a power n. So, e power y dy equal to e power x dx plus x square dx. So, integrating on both sides, integrating on both sides, integrating on both sides, integrating on both sides. Okay, you try yourself. On integration, what do we get it now? That means we have been separated the variable separable and now we are integrating. So, now let us integrate it. Let us integrate it. See, integrating on both sides, see, we get integral of e power y dy is equal to integral of e power x dx plus integral of x square dx. So, what sort of formulae are to be actually applied here from integration? Those formulae we need to discuss clearly now. So, let us have a discussion on that one. So, first formula we need to discuss integral of x to the power of n dx. This equal to x to the power of n plus 1 by n plus 1 plus constant of integration. Here n does not equal to negative 1. This condition must be followed. And integration of e power x dx is equal to e power x plus c. So, these two formulae also we need to remember in order to solve this one. Right now, we can write integral of e power y dy is equal to e power y is equal to, then what do we get now here? Integral of e power x dx is e power x plus integral of x square is x to the power of 2 plus 1, 2 plus 1 means 3 by 3 plus constant of integration. So, therefore, this is the general solution. This is the general solution of the given differential equation. Right. The problem has been solved. So, once again go through it. If you want, you can take the screenshot also. Very, very important problem. You practice it once again by your own. Right. See, given differential okay. So, this is the given differential equation, right. See, the given differential equation is given differential equation is dy by dx equal to e to the power of x minus y plus x square into e power minus y. E power x minus y using a power m minus n is equal to a power m into a power minus n. This is e power x into e power minus y plus x square e power minus y. Let us take e power minus y common. e power minus y into e power x plus x square. Bring e power minus y this side and dx this side. So dy by e power minus y equals to e power x plus x square dx. Now the actually variables have been separated. Again this dy by e power minus y, we can write e power y dy is equal to, open the bracket, e power x dx plus x square dx. Now integrating on both sides, integral of e power y dy equal to integral of e power x dx plus integral of x square dx. Integral of e power x dx is e power x. Integral of x to the power of n dx is x to the power of n plus 1 by n plus 1 plus c, where n does not equal to minus 1. So integral of e power y dy is e power y equal to integral of e power x dx is e power x plus integral of x square dx, x to the power of 2 plus 1 3 by 2 plus 1 3. So x cube by 3 plus constant of integration. So this is the general solution of the given differential equation. So let us proceed for third problem, third question. So all of you note down the third question now. Solve 3 e power x tan y dx right, tan y dx plus 1 minus e power x into secant square y dy is equal to 0. So if you observe the given differential equation, actually it looks like in the form of f of x dx plus g of y dy is equal to 0, but it is not directly like that. But some applying mathematical manipulation, it can be put exactly as f of x dx plus g of y dy is equal to 0. By integrating on both sides, we get the general solution of the given differential equation. Okay. So now let us write given differential equation is is 3 e power x tan y dx plus 1 minus e power x secant square y dy equal to 0. I will tell you a beautiful logic here. How to put directly f of x dx plus g of y dy is equal to 0. Simply, actually here dx is there, it should contain the function of x only. As dy, it should contain only function of y. So that means here it should not be, there should not be 1 minus e power x, there should not be tan y, that's all. So that's why divide both sides by tan y into 1 minus e power x. Exactly this can be put in the form of f of x dx plus g of y dy is equal to 0 form. So that means now divide both sides. So this technique has to be applied also. So divide both sides by tan y into 1 minus e power x. See, then what do we get now? 3 e power x tan y dx divided by tan y of 1 minus e power x plus 1 minus e power x into secant square y dy upon tan y into 1 minus e power x is equal to 0 by tan y 1 minus e power x, 0 by something 0. So now what will happen, you see, tan y will gets cancelled. Here 1 minus e power x gets cancelled. Now actually the variables have been separated. We are separating the variables now. This we can write it 3 e power x upon 1 minus e power x dx. See, f of x, this is a function of x dx, plus this we can write secant square y upon tan y dy is equal to 0. So now we have been separated the variables, as the separators have, variables have been separated, just only the one thing is left, that is integrating on both sides. So let us integrate. So integrating on both sides. Integrating on both sides. So integrating on both sides. So what do you get now? 3 is the constant. So 3 times integral of e power x by 1 minus e power x dx plus integral of secant square y tan y dy. dy equal to, so this is integral of 0 is constant, write down that constant also we can change. So always constant is not fixed constant in any one of the form. If all the terms are in logarithms, we can write log c. If all the terms are trigonometric functions, we can write sin c. If all the functions are in hyperbolic functions, we can write in hyperbolic constant also. So that's why first let us write c, after that we can see according to the problem we can modify the constant. So now this is the form you will be getting. But here one thing just observe, in order to integrate this one, here numerator is e power x, denominator is 1 minus e power x. If you just observe that, so we can find that one of the formulae we have discussed in integration, e power x is the part of the derivative of 1 minus e power x. 1 minus e power x differentiation is minus e power x, but here we have e power x, that can be made minus simple manner. How can you make them in as a derivative of 1 minus e power x? Why not? This we can write like this, minus 3 and integral of minus e power x by 1 minus e power x dx, write down, that's all. So next observe the second term, secant square y is the derivative of tan y. So that means actually numerator is the derivative of denominator. So that's why you keep like this only, integral of secant square y upon tan y dy. So this is equal to constant. So my dear students, here concept need to be kept in our mind, important concept. Without this concept, this problem cannot be solved. So what is the concept means? We have integral of f dash x. F dash x means numerator is the derivative of the denominator. So f dash x by f of x dx is equal to log of denominator. So that is log of f of x plus c, this formula. So using this concept, easily this problem can be solved now. See, how do we write? By applying this one, so this we can write negative 3. So this is the actually f dash x by f of x dx. So log f of x, log of mod 1 minus e power x. I hope it's very clear. Plus this is also here actually f dash y by f of y dy. This is we can write log mod tan y. So all the terms of left hand side is in terms of logarithm. So constant also you can write as a log c, no problem, log c write down. So now once again using power rule, this 3 log of mod of 1 minus e power x we can write like this, log mod, just rearrange the terms, log mod tan y minus log mod 1 minus e power x mod of 1 minus e power x whole cube is equal to log c. So we have one more concept in logarithms. What is the concept? Log a minus log b is there. Log a minus log b is equal to we can have log of a by b for the valid basis. So that we can write this one. So this one we can write logarithm of log of tan y upon 1 minus e power x whole cube equal to log c. So both side we have log. So log of this function is equal to log of this function. So this function must be equal to c. That means actually tan y by 1 minus e power x whole cube is equal to c. That we are going to get it now. So that means next step we can write next step. So here we have, on comparing on both sides, tan y upon 1 minus e power x whole cube equal to c. By cross multiplication, what do we get? By cross multiplication we get tan y equals to c times or c multiplied with 1 minus e power x whole cube. So therefore this is the required differential equation. This is the required, sorry, not differential equation, general solution. General solution of the given differential equation. Okay, I hope it's very clear to you. So we have discussed in clear manner. Okay. So let me explain step by step once again. See, given differential equation is 3 into e power x tan y dx plus 1 minus e power x into secant square y dy is equal to 0. So in order to put f of x dx plus g of y dy, so there should not be tan y, there should not be here 1 minus e power x. So easy technique here, I underline this one. So divide both sides by tan y into 1 minus e power x, exactly it can put in the form of our desired form or required form. So 3 e power x tan y dy by dx divided by tan y 1 minus e power x, tan y gets cancelled, plus 1 minus e power x secant square y dy by tan y 1 minus e power x, 1 minus e power x, 1 minus e power x gets cancelled is equal to 0. So we have 3 e power x 1 minus e power x dx plus secant square y by tan y dy is equal to 0. So now the variables have been separated. Now integrating on both sides. So integrating on both sides, what do we get now here? 3 common, integral of e power x 1 minus e power x dx plus integral secant square y tan y dy is equal to constant. So now actually the derivative of 1 minus e power x is minus e power x. So without loss of generality, here this can be written minus 3 integral of minus e power x, minus into minus plus only. Now plus this is integral secant square y tan y dy by dy is equal to constant. Both are in the form of integral f dash x by f of x dx, that is log f of x plus c. So this we can write minus e power x is the derivative of 1 minus e power x. So we can write log mod 1 minus e power x. Now actually we have plus log this is actually tan y is equal to the constant, we can write any form, this is log c right now. So rearranging the terms, log mod tan y minus this can be written as log mod 1 minus e power x whole cube is equal to log c. Using this formula, log a minus log b is equal to log of a by b. So this is log of mod tan y by 1 minus e power x whole cube is equal to log c. Comparing on both sides, this must be equal to c. So tan y by 1 minus e power x whole cube is equal to c. By cross multiplication, we get tan y is equal to c times 1 minus e power x whole cube. This is the required general solution. Okay, let us move to the next fourth question now. Fourth question. So let us move to the fourth question now. Fourth problem. Find the equation of the curve passing through the point 1, 1, whose differential equation is y minus yx of dx plus x plus xy dy equal to 0. So that means actually here the differential equation of the family of the curves is given, that is y minus yx dx plus x plus xy dy is equal to 0. If the curve passes through 1, 1, what is the equation of one of the equations of that curve we need to find out now. So leave it all these things simply here. We need to find out equation of the curve which passes through the 1, 1 and whose differential equation is given. So just solve the differential equation. First we get the general solution. So if you substitute 1, 1, x for 1, y for 1, you get the constant. Again if you substitute the constant, you will get the particular solution of the given differential equation. That means in this case we are going to find out particular solution. Already we have discussion how many types of the solutions means general solution, particular solution, singular solution, but in this case we are going to find out particular solution. Okay, let us solve. First of all, given differential equation, write down. So given differential equation is y minus yx dx plus x plus xy dy equals to 0. But it seems to be in the form of f of x dx plus f g of y dy is equal to 0, but just check it now. Here we can take y common. Now this we can write like this: y common, we have y into 1 minus x dx plus here we can take x common, 1 plus y dy equal to 0. So just observe, dx means it should contain the function of x only, dy means it should contain only function in y, but here we have y, here we have x. So both should be separated. So how do you separate? Multiply these two terms, x into y, xy. So dividing both sides by product of x and y, that is xy. So to put it variable separable form, so we can write y times 1 minus x upon xy dx plus x times 1 plus y or x into 1 plus y by xy dy equals to 0 by something 0. So now what happens? Y gets cancelled, x gets cancelled. 1 minus x by x, you can write 1 by x minus x by x is 1 of dx plus this can be written 1 upon y plus 1 dy equals to 0. So now actually it is in the form of f of x dx plus g of y dy is equal to 0, which is in variable separable form. Now integrating on both sides. integrating on both sides. So integrating on both sides, integrating on both sides. So what do we get now? So we have integral 1 upon x minus 1 dx plus integral of 1 upon y plus 1 dy equals to 0. So this can be written as integral of 1 upon x dx minus integral dx plus integral 1 upon y dy plus integral dy is equal to constant of integration. See, integral of 1 upon x is general form. This is, you remember once again actually here concept. So these concepts are very important. Once again I emphasize on this one. So integral of 1 upon x dx, derivative of logarithm is 1 by x. Integral of 1 by x is log mod x plus constant of integration. So similarly integral of dx is x plus c. Right, using these two concepts this problem can be, now this integration can be done. Right, here we have this, we can write log mod x minus x log mod y plus y equals to constant of integration. Log mod x plus log mod y, this we can write log xy, log mod of xy minus x plus y equal to constant of integration. Say this is equation 1. This is the general equation, but we should not require the general equation as it represents a equation of the curve. It passes through the 1 comma 1. So let us substitute 1 comma 1. Write down now here. Since it passes through 1 comma 1. So we have, that means indirectly put x for 1 and y for 1 in the equation. Then what do we get now here? Log of 1 minus 1 plus 1 equal to c. Logarithm of 1 is 0 plus 1 0 equal to c. So therefore c becomes 0. Substitute c is equal to 0 in the equation 1. We get required equation of the curve. So therefore the equation of the curve passing through 1 comma 1 is log mod xy plus y minus x is equal to 0, because particular solution c value is 0. So this is our answer. So just go through this question, all of you. Just go through this question. Okay. Let me revise the question once again. This is the question. All of you read the question once again. Find the equation of the curve passing through 1 comma 1 whose differential equation is y minus yx dx plus x plus xy dy is equal to 0. Now the given differential equation is y minus yx dx plus x plus xy dy is equal to 0. In the first term, let us take y common, y into 1 minus x dx, plus in the second term take x common, x into 1 plus y dy is equal to 0. So, as it should be in the form of f of x, like this form, f of x dx plus g of y dy is equal to 0 form. This is called variable separable form. Here it should contain only function of x, but function of y is there here. So, you put dot here. So, in the similar manner, here it should be only function of y, but x is there. Get the product of these two functions x and y, x y, dividing both sides, or divide both sides by x y. Then what do we get? Y into 1 minus x by x y dx plus x into 1 plus y by x y dy is equal to 0. Y gets cancelled, x gets cancelled. So, then we can write 1 upon x minus x by x is 1 dx plus 1 upon y plus y by y is 1 dy is equal to 0. Now, integrating on both sides. Integral of 1 upon x minus 1 dx plus integral of 1 by y plus 1 dy is equal to 0. So, now what do we get now here? This we can write integral of 1 upon x dx minus integral of dx plus integral of 1 by y dy plus integral of dy is equal to integral of constant is c. Integral of 1 by x dx is log mod x plus c. This is the concept, right? Using this concept, actually here we can write here c. This is log mod x minus integral of dx is x plus integral of 1 by y dy is log mod y plus integral of dy is y is equal to c. Say this is actually this log x plus log y, we can write log a plus log b is log of ab. This formula log a plus log b is equal to log of ab. So, this is one of the properties of the logarithms. This log x plus log y log of xy minus x plus y is equal to c. This is the general solution of the given differential equation, but we are asked a particular. So, that is why, since it passes through 1 comma 1 according to the problem, put x is equal to 1 and y is equal to 1 in equation 1. So, log of 1 into 1 log 1 minus x1 plus 1 equal to c. Log 1 0. So, 1 minus 1 0. So, c obviously 0. Substitute c is equal to 0 in equation 1. In this equation, let us substitute. Substituting, the equation of the curve passing through 1 comma 1 is log of mod xy plus y minus x is equal to 0. So, this is our answer. Right. Question number 5. Question number 5. Solve the differential equation. Solve the differential equation. Solve the differential equation. Solve the differential equation. E to the power of x minus y dx plus e to the power of y minus x dy is equal to 0. This is the question. Okay, let us try to solve it. So, if you want to solve by your own, so just do one thing. Okay, Thaudozu Sai Kiran, welcome. Kambalapalli Ramakrishna, welcome. After a long time, right? Right. Given differential equation, is e power x minus y dx plus e power y minus x dy equal to 0. This is the given differential equation. So first, from basic algebra we need to use the one concept here. What is the concept? Let me write the concept once again. The first concept is a to the power of m minus n is equal to, we can write a to the power of n upon a to the power of n, or you can write a power m times a power minus n. That also we can write, both ways you can write. So now this can be rewritten as e to the power of x into e to the power of minus y dx plus e to the power of y into e to the power of minus x dy is equal to 0. So in order to put in the form of, actually this form, f of x dx plus or minus, no problem, g of y dy is equal to 0. This should be exclusively function of x only, but here we have e power minus y here. It should be exclusively function of y. So here we have e power minus x. So multiply both e power minus x and e power minus y. So now divide both sides, divide, let me write once again, divide both sides by e power minus x into e power minus y. Okay, then what do we get, Mr. Ramakrishna and also Sai Kiran? So we can write e power x into e power minus y divided by e power minus x into e power minus y dx plus e power y e power minus x upon e power minus x e power minus y dy equal to 0 by e power minus x e power minus y, you get 0. So here e power minus y will get cancelled. So here e power minus x will get cancelled. So we have e power x by e power minus x. So let me explain the concept actually here. What is the concept means? A to the power of m upon a to the power of n is equal to a to the power of m minus n. Reverse this one, right? So this we can write e power x by e power minus x means e power x minus of minus x, x plus x, it becomes e power 2x. This is e power x plus x, e power 2x dx. Similarly, this becomes e power 2y dy is equal to 0. Clear? Now this is in the form of this one. Directly now we can integrate it. So integrating on both sides, write down, integrating on both sides, integrating on both sides, what do we get now? Integral of e power 2x dx. Even beginners also easily understand my classes. So these are absolutely free classes, no payment should be done here, no payment should be taken here. Absolutely free channel in India, is one of the free channel which has been actually giving a lot of content. You can find more than 1500-1600 videos in our channel. They are absolutely free. So for intermediate, for M.SC, for JEE mains, some sort of JEE questions, even AP, D.SC, TET classes also available in our, even 10th class, NMMS classes, most of the classes are available in our channel. That's also absolutely free itself only. So integral of e power 2x dx plus integral of e power 2y dy is equal to integral of 0 is constant c. Right. So now once again one more formula you need to remember, that is See, integral of e power mx dx, m is constant, this is nothing but e power mx by m. You remember this concept. This is very, very important. Integral of e power mx dx is equal to e power mx by m. So now easily we can write integral of 2x dx is e power 2x upon 2x derivative is 2 plus integral of 2y dy is e power 2y derivative is 2 with respect to y, that is constant, you will get it. By cross multiplication or multiply 2 on both sides, you get e power 2x plus e power 2y is equal to 2c. See, c is constant, 2c is also constant. Instead of 2c, simply you can put c, no problem. So this we can write e power 2x plus e power 2y is equal to c. So this is the required general solution. Required general solution. I hope you might have understood well. If you won't understand, you can live chat with me. But one thing you remember, if you want to live chat, first of all you need to subscribe, because I opted subscribers mode only itself only. So that's why you need to send the messages during live session. Compulsory you need to subscribe our channel. I don't want to be a member of Sakala Vidya. I don't actually accept any fee from you. It's a free class, absolutely free classes, and in future also we will conduct free class itself only. In free classes we will we won't teach only 1 or 2 chapters, 1 or 2 concepts. The most of the problems of respected courses will be completed. So okay, so this is our motto. It's actually started as a mission. So you try to understand and actually encourage our channel itself also. Cooperate with us and stay with us, be tuned to our classes. Right, once again let me explain about this question now before going to wind up our session, today's session. Here what is the given differential equation? E to the power of x minus y, and this is actually dx, don't get confusion. So I will write once again this one, e power x minus y dx, right. This is the given differential equation. So this e power x minus y and e power y minus x, using this concept we can write a power m into a power minus m concept we need to make use of. This can be written e power x into e power minus y dx, plus this we can write e power y into e power minus x, already dy is there, dy is equal to 0. Now it should be to put f of x dx plus g of y dy. Here there should not be function of y, here function of x should not be there. So multiply these two functions, e power minus x into e power minus y. So divide both sides by e power minus x into e power minus y. Why should we multiply? To put in this form, right. So now e power x into e power minus y by e power minus x e power minus y dx, e power minus y will get cancelled, plus e power y e power minus x by e power minus x e power minus y, e power minus x cancelled, dy is equal to 0. Here we have e power x by e power minus x, that is e power 2x dx, plus e power y by e power minus y e power 2y dy is equal to 0. Now it is in the form of f of x dx plus g of dy is equal to 0 form. So now integrating on both sides, integral of e power 2x dx plus integral of e power 2y dy is equal to integral of constant term is c. So now we have very, very important formula in integration. Integral of e power mx dx is e power mx by m plus constant of integration. This is indefinite integration. So integral of e power 2x dx is e power 2x by 2 plus integral of e power 2y dy is e power 2y by 2 is equal to constant. So take LCM 2, cross multiply, e power 2x plus e power 2y is equal to c, 2c can be written as c only. So, e power 2x plus e power 2y is equal to c. This is the required general solution. Thank you. Bye bye. See you in the next class.